Good morning, my friends. We're looking at problem 5.24 today. I've got the free body diagram started. There are a couple things I want to point out, though, before we actually get into solving the problem. There's a statement in the problem that says that member ABC has a uniform cross-section and weighs W2. W2 is 300 pounds. So if it weighs a uniform cross-section, if it has a uniform cross section, it means its weight is carried at the center of gravity. If you take a look in the problem, the picture anyway in the problem says that it's 2 feet from point A to point B, and then it's 8 feet from point B to point C. So this beam is a 10-foot long beam, which now tells us that the weight of the beam would be, let me get it up here, then we'll talk about it. The weight of the beam, which is 300 pounds, is in the center. So 5 feet between point C and what I'm going to call point D. Okay, so it has a uniform distribution or uniform cross section. Because it has a uniform cross section, that indicates to us that the weight is in the middle. It is a 10-foot long beam, so the weight will be in the middle, which is 5 feet from point C or 5 feet from point A. Problem statement is to determine the reactions at point B and point C. So we are looking for By, which is a roller parallel to the surface. Notice I have the arrow pointing down. And of course, we have smooth pins at point C. So X component and a Y component. I thought we'd go real crazy on this one and use the equilibrium equation, something that we have done in all of the problems out in chapter 5. I'm going to start with the equilibrium equation for X. Looking at forces in the X direction, there's only one, and that's Cx. So, and if it's at equilibrium, the summation of forces in the X direction are equal to 0. There's only one force in the X direction, which means that force is equal to 0. All right, summation of forces in the, you guessed it, Y direction. I've got a positive 2,400 pound force at A. I've got a negative force at B, a negative force at D, and a positive force at C. Combine those terms are like 2,400 minus 300 is 2,100 minus By plus Cy is equal to 0. I have two unknowns. That's really not going to help us very much. So we need to take the summation of moments. I'm going to take the summation of the moments about, I'm going to do C. I'm going to do C. So if I look at the summation of moments about C, we already know Cx is 0. Cy will not be a player because the perpendicular distance between where it's being applied and the point of rotation is 0. Point D is a player. Point D is a player. Point D is going to cause a rotation about C in the counterclockwise direction, which is positive. Point C is also a player, also causing a counterclockwise rotation about point C, so that's positive. And point A is player. It causes a rotation in the counterclockwise direction, which is negative. So grab everything that we need. Let's see. So point D we said was a player, 300 pounds. It is 5 feet from point C. By is 8 feet from point C. And A is 2,400 pounds, which I think is 10 feet from point C. Of course, that summation is 0. We said that the 300 pound caused a positive rotation. BY was a positive rotation. 2400 is a negative rotation. Going through the arithmetic, 300 times 5 is 1500. Foot-pound force plus BY times 8 feet plus negative 2,400 times 10 is negative 2,480 foot-pound force. Combine those terms are alike. So combining 2,400, I'm sorry, combining 1,500 and negative 2,400. We get I think I may have misspoke, so let me get the vocabulary correctly. It's 1,500 plus negative 24,000. Combine those terms, they're alike. We get negative 22,500 foot-pound force plus BY times 8 feet is equal to 0. Add 22,500 foot-pound force to both sides and divide both sides. Well, I'll just do it in 2 steps. BY times 8 pounds is equal to 22,500 foot-pound force. Divide both sides by 8. We get that BY is equal to 2,812.5 pounds. The fact that this is a positive number indicates that I assumed the direction at BY correctly. Filling in our scorecard. So BY was down. All right, we can use the summation of the forces in the y direction equation, which we will just bring down here. 2,100 minus 2,812.5 plus CY is equal to 0. Combine those terms, they're alike. You get negative 712.5 plus CY is equal to 0. I forgot to put the units in, so let me do that real quick. Add 71.25 to both sides. We get the force at force CY is equal to 7,125 pound force. It is a positive number, which is an indication that I assumed the correct direction implied, and it was up. So we were asked to find the reactions at B. There was just one. It was in the y direction, and then the reactions at point C, where there are 2, one in the y direction and one in the x direction. Have a great afternoon. I'll talk to you soon.